We now get across to discussing a bit of the statement of Leibniz theorem. I've written it down on the board to save a bit of time and for convenience, both to myself and to the listeners. Now, the focus of Leibniz theorem is to find the nth derivative of a product of two functions which are designated as u and v. So, we want to find u v's of n, where u and v are specified functions of x, of which the nth derivative is known individually. So, that is the starting point. It is very simple to state. We start by first writing nc naught u naught v's of n. Next term is nc1 u1 v n minus 1. Third term is nc2 u2 v n minus 2. We will see that as we come to the general term, it is ncr u's of r v's of n minus r, and that way when we go to the last term, it is ncn u's of n v's of 0, which is n minus n. So, if one focuses on this term, one can write out all the terms, and it can be compacted to sigma form by saying that u v sub n is nothing but sigma n cr u r v n minus r running through 0 to n. This is the compacted sigma form, but we don't need to dwell too much on that. It is easier understood if the terms are exploded and written down in detail. So, once again I repeat that our focus here is to find the nth derivative of the product of two functions u and v, of which, as I said before, the u's of n and the v's of n are known. It is important to notice that this formula can also be written from this side. We have the strength of this identity. NCR is NCn minus r. So, this NCn is actually NCn minus n. So, it is NC naught V naught u's of n. NC naught V naught u's of n. Next term, the previous term will be NCn minus 1, and that will be NC1. NCn minus 1 is NC1, and we get a V1 and u's of n minus 1. So, what this tells us is that the Leibniz theorem, the way it is written down, it is symmetric about u and v. That means you can take any of them as u, any of the two functions given, any of them can be taken as u, and the other one can be taken as v. No problem will be created. But there are certain intelligent choices that will emerge when I do the problems. So, that is as far as the theorem is concerned. Yeah, it does not matter which one you take as u and which one you take as v. Only thing is we must be able to know, or we must know u's of n and v's of n in advance. Now, if this is understood, we can straight away go to a problem. Yeah, there is one more remark which I will forget. I have captured it there, that u's of naught or v's of naught is, these two terms are undifferentiated u and v. That means u naught stands for u undifferentiated and v naught stands for v undifferentiated. That means the basic functions in their forms, original forms, unchanged. So, we will see how to apply this. And also I will make some remarks about the choice of u and v. Normally, one of the functions is a polynomial of a certain degree, say third degree polynomial or fourth degree polynomial, and we know that the successive derivatives of a third degree polynomial will be a second degree, then a first degree, then a constant, and then 0. So that will give us some kind of direction as to how to choose our u's and v's. We'll take a very simple example. If y is x to the power of 3 e to the power of 2x, find y sub n. We must use, obviously, Leibniz theorem. Obviously, by using Leibniz theorem. Now, this is 3 e to the power of 2x. We will write this as u. So, here we go. Y sub n is n c naught x cubed. We write a naught sub, 0 sub, that means x cubed undifferentiated, and e to the power of 2x n times differentiated. So that is the first term. Second term is n c1 x cubed differentiated once and e to the power of 2x differentiated n minus 1 times. One must note that in the basic theorem, the sum of the sum of u and the sum of v, they will always add up to n. If we notice the general term, it was NCR UR V n minus r. So, if we take the suffixes and add them, they will turn out to be always n. So, here also you see 0 plus n is n, 1 plus n minus 1 is also n. The next term will be plus n c2 x cubed differentiated twice e to the power of 2x differentiated n minus 2 times, and next term will be nc3 x cubed differentiated thrice and e to the power of 2x differentiated n minus 3 times. Now, once we get x cubed differentiated thrice, if we do it mentally, first derivative is 3x squared, second is 6x, third is 6. So, we need not write the nc4 and x3 with the sum of 4 because that will be 0. I repeat once again, we know that the u function is x to the power of 3. After 3 differentiations, we will get just 6. Start with x cube, next is 3x squared, next is 6x, after that 6. And then the next derivative, that means the fourth one, will just amount to 0. That we have done in the first lecture in a little detail. So, we will have to stop here and I will just remove this part from the board and evaluate these terms one by one. Excuse my voice, it's disturbing a bit. So, this is actually equal to, we take it on top, y sub n is equal to nc0 is 1. So, 1 times x cubed sub 0 means x cubed undifferentiated e to the power of 2x n. Now, let us see, if we put e to the power of ax First derivative is a e to the power of ax. Second derivative a square e to the power of ax. So if we do n derivations, we will get a to the power of n e to the power of ax. That's it. So when we have e to the power of 2x derived n times, we will have 2 to the power of n and e to the power of 2x. So that we write 2 to the power of n, a to the power of n and e to the power of ax. Next, nc1 is n. So n times x cube differentiated once, that is 3x square. E to the power of 2x, n minus 1, that means 2 to the power of n minus 1 e to the power of 2x. So we've tackled this term, we've tackled this term. Next fellow is this one, nc2, that is n minus 1 by factorial 2, x cubed differentiated twice means 3x square differentiated once more, that is 6x. And e to the power of 2x, so that will be 2 to the power of n minus 2, again e to the power of 2x. So 1, 2, 3 terms tackled. Last term is this one, so we'll rub out these two or these three and just dwell on this part. Oh yes. nc2 plus nc3 n minus 1 n minus 2 by factorial 3. That fellow would be, if this is 6x, the next term would be just 6, and this will be 2 to the power of n minus 3 and e to the power of 2x. So, ladies and gentlemen, these are the terms. We will of course carry out a little bit of simplification so that it looks not so weird. Let's see. We carry on the simplification process and write this is x cubed 2 to the power of n e to the power of 2x. X cubed 2 to the power of n e to the power of 2x plus n into 3x square into 2 to the power of n minus 1 into e to the power of 2x plus n minus 1 factorial 2 is 2, 6x is there, and 2 to the power of n minus 2 e to the power of 2x. 2 to the power of n minus 2 e to the power of 2x. Next term is n minus 1, n minus 2, factorial 3 is 6, and there is a 6 here. There is a 2 to the power of n minus 3 and there is a e to the power of 2x. So, all the terms captured here. We will see if we can reduce this a little further. First of all, this 6 and this 6, they annihilate each other. This 2 annihilates the 6 and gives us 3. Here of course there is n Yeah, this is all right, fine. So we have 1, 2, 3, 4 terms which we will write on top, and of course we observe that e to the power of 2x can be taken as common. E to the power of 2x can be taken as common. So we will do that. Not only that, 2 to the power of n minus 3 is also common. So we will take out the common factors and write out the final result in this topmost line. Need to rub out just a little bit to be rubbed out. So this is equal to 2 to the power of, we will take n minus 3 common. E to the power of 2x goes common. That's it. Now, if we have taken e to the power of 2x common and 2 to the power of n minus 3, then 2 to the power of 3 survives here. So, that is 8x cube. So, this is tackled. Next term, e to the power of 2x has gone, 2 to the power of n minus 3 has gone. So, there will be a 2 squared term here, 2 square and 3x square and n. So, plus 2 square, 3x square and n. So, this term also has been taken care of, n, 2 to the power of 2, e to the power of 2x and 3x square. Next term, yes, there will be a 2 term surviving, e to the power of 2x has gone. So, plus 2 times, there is an x surviving and a 3 surviving. So, 2 and 3x e to the power of 2x has gone, and n into n minus 1. So, that is n into n minus 1, and the last term is this fellow, 6 and 6 have gone, this has gone, this has gone. So, it is just n, n minus 1, n minus 2. So, plus n, n minus 1, n minus 2. For the listeners who are students and likely to write an examination at some point of time on this, I must emphasize that this little simplification in terms of algebra is expected. In fact, ultimately we must write 12x square, 12nx square and then 6x or 6 into n minus 1x. This simplification is expected for full credit. Most teachers expect it.